Good morning, good afternoon, good evening. Welcome to the presentation of MPAI Metaverse Model Technologies, version 2.1. This is the latest version due to be approved finally and published on the 30th of September at the next General Assembly. So what is MPAI Metaverse Model Technologies? It is a standard project by MPAI, the international unaffiliated not-for-profit association based in Geneva. We develop standard for AI-based data coding. We use a rigorous development process. I'm not going to introduce it today, but it's certainly interesting to study it. And our standards have attached a clear IP rights licensing framework. It's not a license, by all means it is not, but it is a set of guidelines that, that patent holders should follow when they license their technologies. So what is the standard? Formally is called technical specification, MPAI Metaverse Model, MPAI-MMM technologies, which is part 4 of this series of a standard. And the name of the standard, therefore, is MMM Tech. It specifies technologies enabling a metaverse instance. Metaverse instance is clearly an implementation of the MM Tech specification, independently designed and implemented in conformity with the MMM Tech specification. So this is what the scope of this standard is. I'll try to show you that this is indeed the case. The standard it's quite thick. It's difficult to say thick because the specification is all online. Each chapter has a web page. So we have something about the processes. So this is a normative part. Processes are entities that do things in the M instance. They capture data, they operate, and they actuate metaverse data in the universe, which is the real world. Items are data types and qualifiers that are recognized. I mean, they have citizenship right in the M instance. Process action, this is quite important because process action is a payload of a request made by a process to another process to act on items or processes and the response of the destination process. Then we have protocols, which is what carries the payload to the destination. Profiles, we have defined 4 profiles. And then we have a set of very interesting, and quite a few now, verification use cases that are examples of application of the standard to typical use cases. APIs and reference software. This is what we have. So what is an MC instance? It's an ICT platform populated by processes, and the processes are not widely free, but they operate under the responsibility of the metaverse manager, third-party service providers, or subscribers. If you are a subscriber, you are in the metaverse through a process. That is what this specification is about. And it operates, so the process operates under the responsibility of one of these 3 people, and according to the rules of the metaverse instance. We'll say more about the rules. The processes perform activities. They do things in the metaverse. They are called actions. And these actions apply to processes or to items. I mean, a process is a process, but it's useful to distinguish 4 types of processes: apps, devices, services, and users. The users are processes representing humans. If they represented directly humans, they are called H users, H for human, and indirectly, the A users, and A is for autonomous. The point is that matters very often are not so binary. You can very well have an H user that has autonomous components in it, but you know the world is in the metaverse as well is complicated. But you know it's useful to say this is directly controlled by a human. This one is under the responsibility of the human, but is free to operate. The users can be rendered as personas. So this is an important point. When you see an avatar in the metaverse, that is not a user. That is just a digital image of a user, which is the process that drives the avatar, which we call persona. Processes are characterized by three aspects: capabilities, what they can perform; rights, what they may perform; and metadata, their features. As I said before, of course, processes have to respect the rules of the metaverse. So here are examples of actions. For instance, if you wanted to author something, there is a service that is called Author. If you have data in a format that you don't understand, you can get it converted by a conversion service. Discover is, of course, this is the future Google of the metaverse, and we are not preventing Google or any other player to introduce a fancy discovery system, but we give something basic so that we can kickstart the MMM. Identify is when you capture data from the universe, then before they can be accepted inside the M instance, I mean, something that has, and the first thing is to identify the data. MMED, so here come, the things get interesting because the obvious thing that you want to do in the metaverse, but there are many more things, of course, is you want to place an item somewhere. It can be a table, can be your own persona, your own avatar. Then you can animate the avatar. Maybe you capture the data from the universe, the data of yourself, or they can be generated, an animation stream that is generated by the autonomous process. And then we have the MU. You understand that MU, M stands for metaverse and U stands for universe. So what you do if you render an item? Item is any type of data that you have in the metaverse in the real world. Okay, so there is an interesting story that version 2.1 has elaborated, and I will present later. Resolve. So you are here in your own metaverse. Of course, we are talking of M instances. You are in your own M instance. How can I get in touch with you? Okay, so there is a service that you can call to do that. Transact, of course, this is a very basic need that you have in the metaverse. So you see that we have user one, user two, we have service providers in between that facilitate the transaction. capture is okay. You're getting data from you're capturing data from the universe, and you want to bring them into the metaverse. So a few things about what I call here things in the metaverse. And these are the items. The word that will appear quite often next to processes, because essentially what the instance specification does is to say what a process does and what an item does. This is very simplified, but the baseline, that is what it is. Item is an MPAI specified data type that may include a reference to rights. What is the right? It's an item, so it doesn't have any right, of course. It doesn't do anything. But it says who can do what on this item. This is the rights of the item. Qualifier, well, qualifier is a big standard that MPAI has developed that provides additional information about a data type, a set of data for automatic processing. We don't want to explain by some means what this data is. If this is an MP3 stream or if it's an AAC stream, no, we don't want to do that. The information is bundled with the data as a qualifier. Metadata is something that describes the specific characteristic of the data. Then a process which is directly driven by an human or autonomous process, or is autonomous, can make available an item to an M instance. So it senses the data from the universe, produces data qualifier and writes, or it can produce the item directly in the metaverse through an authoring service, or it can import an item from another M instance. So these are the three sources of things for the metaverse that the specification provides. So this is a very big list. I'm not going to spend the time on a long time on it, but it is to describe the what I believe is a wide support to many types of activities that can happen in the metaverse. Simple certificate is okay. You are a metaverse manager, and you want to make sure that what you are importing as a process is a good one. So you need a certificate for that. This implies, of course, that there are certificate authorities and so on, but this will be quite out of what we are saying. Simple concept, I will talk more about that later. You see that we have rights. We have rights and rules here. Then we have account, personal profile, process interaction. We have the process action. This is a big thing that I'll talk about quite at length later. Resolution, this is what I talked about before. Finance, we have a few things here. Then we have all the objects that you can perceive in the metaverse. There are quite a few. Essentially, it is a 3D model, audio-visual, speech, and visual. These are essentially that, but they are combined because you can have an object, but you can also have a scene. You can also have the geometry. And then because a scene, the scene descriptors we call them, they are just a snapshot. Then we also provide the events, which is a collection of descriptors over a period of time. We have, these are formats, are data that we have specified in MPAI. They relate to the state of mind of a human, but also of an avatar, because in the metaverse, we are not there as humans, but we are there as avatars. And so the avatar can have an internal state, whether it is true or simulated, that we don't need to know now. Information about space and time. And so these are data types that are used to access different services. A basic point of MPAI that applies very much to the MPAI Metaverse model is that items are data of a data type. So, for instance, visual data can have different formats. And qualifier, as I said before, is a special type of metadata giving information about the data, so that an AIM that processes it knows what to do things right. An object in MPAI is the combination of data and qualifier. And the basic visual object is visual data only of one type with one qualifier and space-time information. And the visual object is basic visual object and visual object in a hierarchical fashion. So a basic visual object is just, okay, a single object. But if you put together different visual objects and possibly in a hierarchical fashion, you have a visual object. So this is an example of the specification of the basic 3D model object. Of course, this is quite an important object in the metaverse. This is not specified by MMM, it's specified by the object and scene description standard that I have presented this morning. So as you see, okay, here you have several data, but the interesting thing is are the attributes that you can have to a single visual object. It can have a mass, it can be material, or it can be immaterial. It can be subject to gravity or not subject to gravity. If it has a texture map, here's the ID. And, you know, there can be an object, and an object can have audio characteristic. And I will say more about audio characteristic later. And an object, well, an object can have axes, and it's important to say which are the axes that will be referred to by other processes. Then we have the space-time information, and so we have also this thing called annotation that you can add to an object. Then we have the notion of right. Well, this is just a repetition of what I said before. These are a description of who can do what on this basic 3D model object. This is other rights. So this is the audio source, something that we have introduced in version 2.1. So an audio source can have a diffuseness, or it can be directional, or it can have a shape generated by a source that can have a shape and a size. Then we have a possibility to annotate, and again, we have the possibility, say, to turn on and off the audio source, but also, because there is another action that allows you to change the properties of an object, you can change the properties of the audio source. Light source, well, similar, but of course it's a different space. As we see, it can be a point-like source. It can be directional. It can be a spotlight. It can have an area with a shape. It can have a certain color. It can have an intensity. It can have annotation, and it can have, of course, rights. For the object audio characteristic, so all this information could be added because MPAI is really a multi-industry body. We have a very good audio group, and they have developed this specification. So we can have reflectivity. These are early reflection and late reflection time. Reverberation, RT60, 30, and 20, and EDT, or diffusion or absorption. So we can define, so if we are in a room, that a particular wall has a certain object audio characteristics. Texture map, I mean, we have identified the type of maps that can be added, and here you have the list. And with that, temporarily, I will leave the item part, but we are not done with that, to go to the other major component of the standard, which is process action. And so the titles say that for process in need of help So a process may want to do something, but for some reason it cannot do. Um, and it cannot do it because it does not understand the format or other information that is attached to a bunch of data, which is called qualifiers. It does not have the necessary capability. So, for instance, it is unable to handle audio information, while, for instance, it's able to handle visual information. And among the risks, the rights that it holds, there is not a right to perform that particular action that is required. So what is a process action? A process is a kind of speech act which describes what process one requests the process two to perform if an event occurs. So let's go to an example. Well, the process action is composed by the following data: an action, and there are 29, I believe, actions that we have specified. A sequence of what we call nil, at, from, to, and with. So these are complements. The first one is not a complement. It represents the case of a direct object. So we wanted to facilitate the parsing of a process action request by means of this. And then we have if an event. And what is an event? Well, this is interesting because an event is a logic combination of process actions. So if you come into the room and he sits down on a chair, well, that is an event. And all this can be expressed by process actions. Additionally, not any time, but say at a particular moment or during a particular duration. And of course, the process action is composed by a request that is made to the destination and a response of the destination to the source. So here we have a simple example of what happens when a user wants to MMed, which is to place a persona at a location with a spatial attitude. Spatial attitude is the term that we use to indicate the position and orientation. So we have MMed, then we have the request. So we add a particular avatar at this location with position and orientation. And what is this model right? Well, because not necessarily I have already the right to place an object there. So if I say, I want to place my avatar inside your room, you will not be happy, right? So then this is a request, and the request is a request that contains rights, but in a form that is a model. These are not rights yet, but if this request is accepted, they become right. And possibly I can even pay. So if I wanted to participate in a virtual concert, I need, well, I need the right to participate, and so I send the model right, but then I may be asked to buy a ticket, and that's what the transaction is about. The response will be, if all went well, rights and a process action status. We'll say more about this later. So this is the table of process actions. You have, say, for instance, the discover. It's very important. Identify, animate in the metaverse, and animate from the metaverse to the universe. We have transact. We have MMed. We have talked already about that. But also MUAD. In this case, you are placing something that is in the metaverse, you are placing in the universe, and so on and so on. So 2 words about rights. So what's rights? Rights is made by, so we have two types of rights. The rights of a process and the right of an item. Of course, these are the rights attached to an item, not the rights of the item. While before, it's the rights of the process to do something. We have a deontic verb, may not, or must. We have a process action, one of the 29. And then we have one of the 29 plus the list of complements. And then we have the level. What's the level? So when you register and you say, I wanted to place in the metaverse two processes. So you are given the right to have these two processes operating somewhere in the metaverse, and these are called internal rights. Acquired rights correspond to, say, the case when you buy a ticket for 1 hour to enter a particular place and listen to what's happening there, and granted. So if you wanted to go to your friend's room, your friends is better give you the rights unless you are so friendly that you have permanent right to go there. Then we have the rights associated to the item, and this is made by a list of processes that can act on the item, and for each processes, exactly the same thing that we have for the process right, deontic verb, process action, and level. Rule. Well, rule is you have process. I have to say more about this. A deontic verb and a process action. So a rule is a collection of process action with the type of process that can do or not do. The process is identified by an ID, but this is not really good for a rule because a rule should express general principles. And therefore, you have to look at the metadata that are inside of the process to know if that rule applies to you or not. Then, of course, in the process action, we may have many items. And how are they identified? They're identified by a certain metadata, by qualifier, or by parameters that are inside the item. So this is a very simple animation of an M instance. So you see here we have a human, we have a device, we have a user, and the user is rendered as a persona. Here we have an object that becomes an item. Then we have, now that the user is talking to a service, but the service is talking to another service, there are other items involved. And here it's more complicated. So here have human 2. Human 2 is rendered, has a user 2.2 process that is rendered as one persona. But we have the user 2.1 who is rendered with 2 personas. Why not? You can duplicate yourself in the metaverse. And here we have another case. Who said that a user must necessarily be rendered as a persona? It can very well be a process that you are there that does some work for you, and you want to know the result, but you are not interested in showing the process, displaying the process as an avatar. So let's go now to the protocols. We have a basic protocol, which is called inter-process protocol. It's very simple. You have a process action request from process 1 to process 2, and process 2 sends back a process action response. And then we'll have to see what is inside that, but this is the case when you have 2 different instances. So this is more complicated, but you know, thanks to the resolution service, this is exactly what I am describing now. You will see that we start from process A1, sending a request action to a resolution service A. Resolution service A is like the customs of your country. So the custom talks to, which means that forwards your request to this other resolution service, and this other resolution service finally delivers the message, or whatever it is, to to the target process. The target process may not be able to understand because the data type that we are using here are not used in this other in this other metaverse. So you get a conversion service, and you have the so you have the item converted. So the response can be created, sent to the resolution service, sent to the other resolution service, finally back. And now the same thing may happen because you need the help of conversion service to understand what the answer is. So let's go to some example because this is really interesting. So you want to post an item, an NFT that you have and you wanted the help of a marketplace or service. So what do? So you are user one, and one you wanted to post an item. It sends a simple contract, but only as a model, because this is not a contract yet. And the simple contract, because we are talking of the simple contract that the MPAI specifies, but there's no intention to say that this should be the only contract that is used in the metaverse. So this is sent to the service provider. The service provider sends a response to the user. So the response is no, too bad, that's the end of the thing. If it is yes, then user one transacts a pre-value. Sender pre-value is the name they give. So this is what is paid to the service provider for having the right to post the item. And then this is not the end. The seller, the intended seller, sends a service provider license that gives the service provider the right to post the item. So, I mean, things must be under control. And this is sent to the service provider. The service provider, for the time that has been assigned, operate as established by the license. When it is the end, the service provider stops operating for the service according to the service provider license, and the user one recovers the full rights of the item. Because before, by virtue of giving the right to post, probably the service provider says you will not have the right to sell your item. I mean, all this is not established. It's all flexible depending on the format that we use. And so what is in a simple contract? Here we will see the data that we have seen. So we have the sender data. Sender is the seller. The receiver data, the buyer data. And then we have the service provider data. And finally, we have the basic contract status, something that says that the contract is only a model, and the other one that is the final in the sense that it is a real contract. So in the sender data, we have the sender pre-value. Then we have the service provider license, the one where the seller gives the right to the service provider to post the item. And then we have a sender post value, because if there is an interested buyer, the service provider may want it to be paid an additional fee. Then we have the receiver license, the license that the seller is given to the buyer to the item. And then, of course, the wallet. In the receiver, pretty much similar things with the receiver wallet, and here we have the receiver wallet as well. Now, let's see the licensing protocol. So we assume that now there is a user 2, which is here, who is interested in the item, and the user 2 sends a model simple contract. Again, it's just a model because you don't know. Maybe the service provider no longer wants to sell it. So this is sent to the service provider. The service provider, if everything is okay, sends and acknowledge, then the user too pays the service provider in case the service provider wants to get a fee from the buyer as well. And then, of course, it pays the sender, the seller, for the right to the item. The user one now has to pay, in case that this is required, for an additional fee, because now the item is going to be sold, and it sends a model license to whom? To the license service. The license service sends back the same model license in acceptance. Then the seller sends an acknowledge. This triggers the service provider to send the license, the final license, to the buyer, and also send the license to the seller. So this is how we have two basic protocols. Of course, more can be developed. We change the scope here, because we are now talking about the relationship between the metaverse and the real world. So this is when you have an object, or you have an item in the metaverse, and you want to actuate that object in the universe. There is a need to say something more about what is the meaning of actuate. But so this is the time. Yes, of course. Then we have the complements of the requests, and the requests say that it can be an item, or it can be what is contained in a location. Location is a portion of the metaverse space. And this is where should be placed at the U location. So it is an actuation. The actuation should happen at a U location. And what does actuation mean? So we have identified three types of actuation. That you wanted to bring a real object. So we have an example that I will introduce later of a robot. You want to instantiate a robot which corresponds to the user in the metaverse. Or you want to synthesize an object in the universe that corresponds to the item, or you are simply rendering the item, say, on a screen or as a 3D object. That does depend. So this should have a spatial attitude, position, and orientation. And again, not necessarily you have the right to do it. Therefore, you ask for more the right, and you may have to pay in order to do that. And in response, you will get our item, the rights, and the status of that can be okay or can be an error. Now we see examples of errors. For instance, you are asking to do something, but you have a clash. You are asking something, but it is not syntactically correct. You are calling for an ID, but that ID does not exist. You are sending data or qualifier that are incorrect. You want to do something, but you don't have the right to do that. You need to pay, and you say pay, but the wallet does not have enough money. You are identifying a location, but that location does not exist. You want to post something to a service provider, but the post is refused. Or you are sending data with a qualifier that, I'm sorry, we are unable to handle. So these are examples of error responses. So this is the R item. So the R item, the R, of course, means the real item, which is a physical object. So let's say here, so we have the item ID. This is the ID of the item in the universe, in the metaverse. This is the R item ID in the metaverse. The type is one of the three types that I said. It is real, it is a synthetic, or it is media. And where? That's what an item is. So let's go now to two use cases. We call them verification use cases. So these use cases have been designed to test the availability of technology to implement the use cases. Of course, we have, I think, a dozen use cases. By that, we don't claim that everything can be implemented. But, you know, the scope of the 12 use cases is sufficiently wide to justify the claim that we have a sufficient scope for of use of this specification. So the co-design across metaverses. So we have a company A in an instance A that commissioned the design of a new car to company B, but the company B is based in another metaverse instance. So the user B, which is a company designer, the designer of company B, produces a 3D model object, which is composed of different 3D model objects that constitute the design of the car. The 3D model object includes different versions of the car elements, rear view mirrors, dashboards, cabin lights, and you know, because we have the material attribute of an object, you can put many rear views at the same place, but only one real view is the one that have material and visibility characteristics. And this will be used later in the use case. So there is a progress meeting. The progress meeting is held at the room B in the metaverse B. Of course, it is attended by the customer and the designer. Well, customer is not the real word. It's the company representative. So the user B, we add that it has full rights to act on the car model and in the room B. So what happens? So this is simply an example of how the resolution service operates. So user A initiates a session and requests resolution service A to open contact with user B. But this cannot be done directly, as we have seen. So resolution A forwards the request to resolution service B. Resolution service B forwards the request to user B. User B responds to resolution service B, accepting the invitation. Resolution service B forwards the response to resolution service A. And resolution service A forwards the response to user A. So this is how the resolution service operates, the resolution protocol operates. So then we are now in the real meeting. So because of that, we have user B, which is the company designing the car. So as the car model B at a place in room B, and of course the perceptibility status of the car is on. And then he grants rights to user A to act on car model B and to act in room B. Okay, so now user A is in their metaverse, but can act on things in room B, including the car. So how is the meeting going to happen? User A looks at the result of the design, and what does he do? He changes the properties of rear mirror 1. And the rear mirror 1 now is no longer perceptible. And also immaterial. Then it changes the properties of rear mirror 2, which is in the same place of rear mirror 1. Before it was not perceptible and was not material, but now it makes perceptible and material. Say now it changes parameters of rear mirror 2, and for instance, it resizes the mirror, the rear view mirror. So this is how it is. So this would take a long time to introduce. So I will skip most of it. So this first part is how the resolution service operates. Then we have a user B giving the right to user A1 to come to the room. Then a user A places themselves as their persona somewhere, and of course you want to be visible. Then we have user B places the car model, blah, blah, blah. And here we have user A that does all the property changes that are necessary to assess the quality or the fitness of the rear view mirror. Second and last use case. So an example of emergencies in the industrial metaverse. So you have an M location in the metaverse that has a digital twin of a real factory. Now you have, and this is what we call a virtual factory, V-factory. Then we have an autonomous user that is activated when there is an emergency and has the rights to actuate and to animate, of course, an emergency robot in the R factory, and is rendered as a persona having the appearance of a robot. So we have a user, which is an autonomous user, that can manipulate the robot in ways that the use case, of course, does not describe. So if there is an emergency, this emergency user activates an alarm in the real factory, and it can do that if it has the rights, of course. Then MU actuates the emergency robot in the real factory, and this is done by calling the robot from a repository to the place where it is needed, animate the robot to solve the problem, and renders its persona. So it is an autonomous user, but can have a persona rendering itself so that humans can see what is happening in the real factory. So assume that this is a real factory where humans cannot enter for any reason, but of course you can have robots that can do that, and the metaverse can manipulate the robot. So when the emergency is resolved, the robot is moved to its repository. So here is what happens. We have a user 1 that activates the alarm at this place. Then we have this user 2. This it represents a human that wants to see what is happening. So it renders the scene at maybe at their home with a spatial attitude, asking for certain rights. Then we have the emergency user that adds the robot from repository to a particular place using a trajectory. So this user can specify the trajectory that the robot should follow to reach the place. And again, we need a model rights. So then we have a process of animating the robot. And when the things are done, there is an instruction to move the robot back from the place where it was to the repository. And of course, assuming that certain rights are available. Two words about the software, the reference software architecture. I don't know if we have Alberto here so that he can give 2 words. Probably we don't have him present. So anyway, the idea is that so here you see what happens in the universe, and here's what happened in the metaverse. In the metaverse, you have users, and here you have devices and humans, and so we have services, and then we have the metaverse service, and we have different sub-metaverses where things can happen. So the implementation has been made with Unity. And here is just one image from the implementation. 2 words about the profiles. So we have a baseline profile, which is very, very simple. I mean, we don't have security. This can be interesting for a closed environment application. We have one that is focused on finance. So you can, for instance, trade NFTs and so on. For that, you don't even have the need for avatars. So this is simple in a different sense. The management profile is quite rich and includes the 2 plus a lot more things. And we have the high profile that adds a few more functionalities to the previous 3. Conclusion. So I like to say that the MMTech version 2.1 is a metaverse specification, because of what you will hear. It can be used to interface with any platform like Unity. And indeed, it has been implemented for Unity as an open source software Unity applications. And the actions and the items specified by MMTech allow interoperability between different various MMTech implementation. So you have your own implementation that sits on top of Unity, but another implementation can use Unreal, for instance. And but you know, the 2 are perfectly interoperable because the data that are represented the activity are actions and items, and these have the same representation. Because of that, I'm very happy to close this presentation. Looking forward to working with you on this exciting MPAI project. You are welcome to join MPAI and share the fun with us and build the future. And so here you have a link where you have the specification. It's a series of web pages, and you are welcome to send your comments by the end of the month. With that, thank you very much for your attention, and I will be happy to hear a question and try to answer as best as I can.